about the equations for each of these lines. I'm going to write them down, and if you had any trouble getting them, let me know and we'll go over it, okay? So what did we get for the equation for the first line? Someone want to let me know what you got for the equation? Y equals 0.3x plus 2. We okay with that one? Okay. How about the second line, which is a constant, right? It's a constant horizontal line. So y is always the same value between 20 and 8. And what is that? What is the value for y? 8. Yep. So those are the ones you like to see because they're pretty easy to fill in. Y is just some constant number. And then the last one we noticed, we have a negative slope. Here we had a positive slope. It was increasing. Here we had a constant value. It wasn't increasing or decreasing. And now it's decreasing. And so what did we get for that one? That was probably the hardest one to find. Other than Alex? Negative 2 over 5x plus 20, right? And if you want to write that as a decimal, it would be negative 0.4x plus 20. Any questions on finding those three equations? All right. So notice here how we have a different formula for different parts of a domain. So I'm going to use three colors here. So from 0 to 20, we are using this equation, right? So just on that little part of our domain, from 0 to 20, my line is increasing at this rate, 0.3 thousandths of a gallon per hour, because that's what's down here. Well, we don't know this yet. I'm going down a few here. Then we break up the domain from 20 to 30, and we have another formula. We got three different formulas. And then from 30, whoops, that should be red. From 30 to 50, we have a third formula. So if we were trying to write a function for this graph, we couldn't say f of x equals and then just have one formula, could we? Because we've got three different pieces of our domain where something's happening that's very different than the previous line. From 10 to 20, our line is increasing. From 20 to 30, it's staying the same. And then from 30 to 50, it's going down. So if we were trying to write some formula for this, it would have to have three parts to it. It would have to have three pieces because there's three separate line segments here. Okay. So this is what we call, this is a little introduction into functions that we call piecewise functions, because they come in pieces. And sometimes they have 2 pieces, sometimes they can have 5 pieces. It depends on the situation. And there are many things that require piecewise functions, like late fees. You have a certain late fee for so many days, say on your credit card, you have a certain late fee. But then if you go over that many days for your late fee, it increases to something else. So you would need two parts at least to describe how to figure out a late fee on a credit card. Our tax system, if you're in our business program and you've taken accounting or our tax course, you know that on various levels of our income, we have a certain percentage that we pay for tax. It's not a flat tax like our sales tax in Massachusetts, right? We go out and we buy something, no matter whether we buy something for $25 or $350, it's the same percentage of the tax. Does anybody know what the Massachusetts tax is? 6.25. So 6.025. Okay. So there's lots of situations when we're describing a relationship between two quantities where we have to use more than one equation. And here's a little scenario right here. So let's take this graph, and now instead of it just being X's and Y's, we're putting some meaning to this graph. So along our horizontal axis, we're measuring time in hours, and along our vertical axis, we're measuring gallons of water in a pool in thousands of gallons. So the graph below represents what we call a piecewise function, because it comes in 3 pieces. Our time periods are broken up into 3 pieces depending on what's happening in the pool. Okay, so let's talk about how the water has changed in the pool over the domain. See, remember, your domain is always along your horizontal, your independent variable. So we're going from 0 hours up to 50 hours. So let's start the sentence. Table 1 can start somewhere, table 2, and then Alex will have to represent his whole table and finish it off. So start us off, table 1. How about Felicia, you want to start us off with how the amount in the pool's changed? You have no idea? That's okay. How about Maddie? So we're talking about how the amount has changed as we move from 0 to 50. Okay, so you want to, so the amount of water in the pool has increased. Do you want to tell me any more specifically? Well, how about the time first? Yeah, the first 20 hours, right? So the amount of water in the pool has increased in the first 20 hours. Right? So that takes us from 0 to 20, right? That's this first piece of our domain right here, 0 to 20. All right, it's increasing. Okay, you want to continue with that? Table 2. Right. Between 20 and 30 hours, the water level remains constant or stays the same. Remains the same. And then finally, Alex. The water level decreased. Okay. Okay, so without finding the formulas, the slopes, that's the best we can do. We can talk about what's happening. See how I have 3 different colors along my domain? The first 20 hours, one thing's happening. The next 10 hours, something else is happening to the water level. And then the final 20 hours, something else is happening to the water. Okay. So without the actual formulas here for each of those lines, I can't really say that it's increasing at this rate or decreasing at that rate. Okay, but just from looking at that, that's what we can talk about in terms of the pool. Now remember, when we talk about intervals where water levels are increasing, decreasing, or staying the same, we use interval notation, and it's what kind of intervals when we're talking about increasing, decreasing, and constant? What kind of intervals? Open or closed? Open, right? From our work on, what's today? Wednesday, on Monday. So what interval, and I don't have open in there, but we know that our author wants us to use an open interval. Over what interval is the water level in the pool increasing? 0 to 20, thank you. Okay, and that's how we write it. Remember, it's always expressed in terms of our horizontal or X horizontal variable, our independent variable, which we tend to call X. We don't talk about the heights of the water here. Okay, what about the water? What interval is the water level constant? 20 to 30 with parentheses. And then finally from 30 to 50, it's decreasing. So these three intervals, 0 to 20, 20 to 30, and 30 to 50, define different pieces of our domain. And that's why that's one of the reasons why we call it a piecewise function. Because we're taking whatever would be our normal domain and we're chopping it up. And we're talking about a function over each one of those domains. So here's the equation that represents the pool. You found all of these equations. So let's fill this in. This says that the number of gallons in my pool, G, based on the time I'm given, will be this formula, 0.3 times T plus 2, if the time is less than or equal to 20 hours or greater than or equal to 0. That's our first domain. First part of our domain chopped up. And then it says the number of gallons in the pool when the time is more than 20 hours but less than or equal to 30 will be 8 gallons. So now we want to write the piece of the domain right here for when the water in the pool is decreasing. So how would I write the domain right here, that last part of the domain? When it's greater than 30 or less than or equal to 50. So I want to just talk about, because sometimes students say, well, when do I put the less than or equal to? And then like on 20, do I put the equal to 20 up here on the first formula? Or do I put it on the second formula? You just make up your mind. Since I can connect this function with without taking my pencil off the paper, you see, I can connect it. All these different parts of my function. If you decide to make T equal to 20 in your first formula, let's look and see what the value is. If I put 20 in here for T, 0.3 times 20 is 6. And what's 6 plus 2? 8, right? Because we know it's 28. So let's suppose you didn't put the equal sign there and you put it there. What would be the value at 20? 8. So it doesn't matter. So if you choose in this case to make the last number that's the endpoint of your domain the equal to part, then you would start off the next piece without the equals there. It's just like your choice. Okay, it's really up to you. So what I wanted to do is just show you in general how you want to think about these piecewise functions. So here's a situation where you have 3 different formulas to describe what's going on in this pool. So in general, you could just write this generally for any piecewise function. So for any piecewise function, this is how you represent it. So let's just say f of x here. F of x will equal, and then you just put this big kind of profile brace like that. And don't forget your equal sign. A lot of people forget their equal sign. You're writing an equation here for a function. So if we followed this little scenario here, we would have formula 1, and we write if. Notice how we have the word if, and then you write the domain used for formula 1 right after it. Okay. So you put your little formula in, and then you write a comma, and then you say if, and then you write the domain that that formula applies to, the part of the domain that that formula applies to. So 0.3t plus 2, f of x equals, so you'd write here, f of x equals 0.3x plus 2, or g of t, I guess. Let me go back here and use the same variables as the function itself. So here you would say G of t equals 0.3 t plus 2. So that's the formula over this part of the domain. Okay. Then I'm changing colors. You might have another formula, formula 2, and you'd write formula 2 in this case it would be 8. And then you write if, and then you write the domain we use to get formula 2. And then finally, sometimes that's sufficient. Sometimes the piecewise function only has 2 parts to it. But in this case, we have 3, so then we have formula 3, and then we write if, and then you write the domain used for formula 3. Okay. So this is the notation that we use anytime we write a piecewise formula. I mean, a piecewise function. Okay, that's the notation we use. So notice I didn't write G of t equals 3 times, right? I wanted to save a little of my ink here. I have 3 different formulas, but I just say G of t is going to equal one of these different formulas depending on my time. That's why it's a function in terms of time. The number of gallons in the pool explicitly depends on how many hours after you've filled the pool. Or in fact, how many gallons were in the pool before the water level started rising? 2 what? 2,000. Not 2 gallons, but 2,000. Okay, look at your units. All right, so let's take a look at the next piece. So here's another situation where you could have a piecewise function. My cell phone plan, and at the time, this was true. I'm not making this up. This was before I went to the Share Everything plan and got and wised up. My cell phone plan with Verizon Wireless charged $79 a month for 700 minutes. And any minutes over this allowance was charged at the rate of 45 cents a minute. Can you believe I once existed on that plan? So if C is the monthly cost in dollars and M is the number of monthly minutes used, find and interpret each of the following. So we don't have any formulas yet, but I've expressed this function verbally to you. And now we want to figure out, how would we actually figure out how much 535 minutes would be if in 1 month I talked 535 minutes? How much would I pay? $79, because as long as I'm under 700, I just pay that flat fee of that flat monthly fee of $79. So one of the things you'll be doing on quizzes and tests is you'll be interpreting what function notation means. So notice, where did I start? I started with the number of minutes. And this number 79 is cost, it's dollars. C of 535 is exactly the same thing as the number 79, and the units is dollars. So when you interpret this, one thing you could do is you say, okay, I started with 535. Put your units right there, minutes, and what I have to pay is $79. So if you do that, then you can just write a sentence that go left to right now and say, okay, if I talked for 535 minutes, my monthly charge would be $79. Okay, remember, both relevant numbers and both relevant units, always, always, always. Okay, and if you do that, then you're really golden. All right. What about 850? How would I figure out my charge for $850? All right, so first of all, no matter what, I'm going to be charged that initial fee, $79. So no matter what, I'm always going to start my cost with $79. And then Courtney said I would do 0.45045, that's the charge per minute, times 150. So there was something that went on in her mind before she got to the 150, which I want to capture. Because sometimes we take these things for granted, how well our mind works. So I agree with what Courtney said. How did we get the 150? How did we get the 150? What? Right, we take the minutes talked, in this case. No, how many minutes did we talk? So the minutes talked, 850, minus the 700, right? Okay, and that's how Courtney got the 150. So if we were to figure this out, we would take 0.45 times 150, and we would add it to 79. So let's do that. 0.45 times 150. Is 67.50, and we add that to 70. So if it was 80, it would be 147.50. So it's going to be 146.50. All right. And you would interpret this the same way. If I talked for 850 minutes, then my monthly charge would be $146.50. There was one month where there was a family emergency and the time did go over 700 minutes. And that's when I started looking. And at this point, neither of my teenage daughters were on the phone yet, so or else I would have been in trouble. So yeah, so thank goodness I found that they had this new plan. And I think at this point I wasn't texting. And then of course I started texting, and I had to keep track of my texts and my minutes until I went to share everything. That was a problem. All right, so do you see that this, if I was thinking about the domain, which of my variables here, cost or number of minutes, is my domain? Number of minutes. Okay, number of minutes is my domain. That's my independent variable. I have total freedom to talk as many minutes as I want, but once I have that number of minutes, my cost depends on it. So if we were graphing this, we would have C, which is the cost in dollars, on our vertical axis, and M, the number of minutes, along our horizontal. And we just said, how would I break up the domain here? What are the two parts of my domain if I broke my domain up? What's the key idea here for the number of minutes? Where does it change? After 700, right. So the first part of my domain goes from 0 minutes, including 0, right up to 700. Okay, that's domain part 1, right? Domain part 1. So over here I could say if the number of minutes is less than or equal to 700 and greater than or equal to 0, if. So I'm actually looking at what part of the domain I'm on. That's my domain, that's the part of the domain. What's the formula to determine the cost if I talk between 0 and 700 minutes? Gabriel? Just 79 buckaroos, right, 79. So there's my first formula. So I would go up here, and what kind of line is this? C of M equals 79. Don't say straight. What kind of line is it? Excuse me? Constant. A little more than constant. Horizontal. Okay, so if I talk from 0 to 79 minutes, 0 to 700 minutes, I'm paying $79. The minute I talk over $79, the minute I talk over 700 minutes, this amount starts to increase. And what's the slope of that increase? Right, 45 cents a minute. So that's the second part of my domain. That's this part all the way out to, well, I guess there would be an end. You couldn't go to positive infinity, but there's, you know, there would be a limit on how many minutes you, I suppose your limit would be the number of minutes in a month, right? If you talked every single minute. So we're just going to say, we're going to make it easy for ourselves. Now, this part of the domain, we just say if m is greater than 700. That's all we have to say. We know in reality there is another endpoint out there, but we're just for the sake of making it easy. So let's look at how Courtney figured this out. Well, if we talk for more than 79 minutes, 700 minutes, we have at least the minimum payment of $79, right? So we're still sitting right here at 79. I could probably make that pink and green, right? At 79, at 700 minutes, I'm going to be paying $79, regardless of which one of these formulas I'm using. Here we are, right there. And then after that, I'm going to start increasing by 45 cents a minute. Notice there's no holes, there's no jumps, there's no gaps. Even if it's 701 minutes, it's going to be $79 plus 45 cents. So it's going to be a little bit higher than the $79. So this is 79 plus 0.45. How do I write this now? I don't have my number anymore in there to write. My 850. What do I put in there? Michael, do you know what I put in there? M minus 700, yeah? So that's if M is greater than 700 minutes. So I'm just looking at the overage, right? How many minutes over 700? And I get that by subtracting 700 from the total number of minutes. So that's this green piece right here. All right. So this is how I would do this particular function as a piecewise. The formula, and then the domain for that formula. Formula number 2, and then the part of the domain for that formula. And you always have this if statement here. You say this is how I determine the cost if I speak for that number of minutes. And this is how I determine the cost if I talk for that number of minutes. Any questions before we move along? Okay, now we sort of have a regular old sketch of a function that's just algebraic. It doesn't have any interpretation at all. No story to go with it. So where's that one point that, first of all, how many parts of our domain do we have? How many little segments? How many parts are we breaking it up to? 2, okay? So because we have one formula if our x value is less than 1, and we have a totally different formula if our x value is greater than or equal to 1. So I come over here to 1, and I just mark it on my little thing. And I know that part of my domain is going to be from negative infinity to 1. So I've got to have a green formula. That would be x squared, because that formula is going to apply over any x value that's less than 1. And my blue formula, which is 1 minus x, is going to apply when I'm greater than or equal to 1. So there's the 2 parts of my domain, the 2 pieces. So right away, I know that I should see 2 different functions. One function on the green part of my domain and one function on the blue part of my domain. So let's look at the green part. The green part says I'm x squared, right? Y is x squared, f of x is x squared, if x is less than 1. So we're pretty familiar with that function. If I'm at 0, I'm 0. I better use green. If I'm 0, I'm 0. If I'm negative 1, I'm 1. If I'm negative 2, I'm 4. If I'm negative 3, I'm 9. Oh my goodness, I'm doing a straight line here. Get with it, Kavanaugh. Okay, -1, 1, -2 is 4, -3 is 5, 6, 7, 8, 9. Can't go much higher, right? And -4 would be 16, it'd be up here. So it's this parabola. I'm coming down. I'm really happy, all the numbers. And then when I get to 1, what do? I can't say I'm 1 because this formula only applies to all the numbers below 1. So any number below that, any fractions being squared, and then I come up to 1. So what do? I put an open circle like that. I could continue this function. See, I just draw an x squared like this. Here, let me show you one way that I saw an animation do this. It was really cool. So what the animation did is it just drew y equals x squared in like this, right? That's y equals x squared. But we don't have the entire real number line for x squared. So then what the animation did is they said, okay, we've got to start erasing until we get to 1, which is where we stop. And that's where we put an open circle. Now you can think about the next part of this domain is from 1 out. So when x is 1, what's the value of y going to be? Yeah, let's see. When f of 1 is, we got to use the blue formula because we're on the blue domain. So 1 take away 1 is 0. So at 1, I am now a 0. And now I just decrease by 1. I go down by 1. I'm a straight line. So I join those points with a straight line, and that's what I look like. So you draw. Colors really help you here. If you use colors and pencils, that's why I put rulers on your table and all kinds of colored pencils in that little toolkit. You can chunk out your domain, and then you can just graph the formula that applies to that domain. All right. Any questions before you take this away? All right. Of course, if you have any questions, let me know. And the other thing is, if you didn't get a chance to finish up your last class activities, if you finished today, go back and finish those up. Especially the one with the tea, right? The tea cooling down. All right.